So, hello everyone. So today I'm going to talk about software installation on Compute Canada clusters using EasyBuild. So for this, let me so for this talk, I will start first by introducing Compute Canada software stack. Then I will talk a little bit about some software that is installed locally on users' directories. Then I will introduce EasyBuild. I will talk about the concept of EasyBuild and some basics of EasyBuild and show examples and do some demonstration on the cluster. So when it comes to installing software, there are many package managers. For example, if you are working on cloud or your own machine, if Ubuntu, for example, you can just use sudo apt-get install. On CentOS, sudo yum install. But this is just your machine, so you have root access. You can use that. But on HPC cluster, users don't have sudo access. So there is no need to ask for it because there are ways to avoid using sudo access if you want to install the software in your home directory. In the case of Compute Canada cluster, we have also a project that is a shared file system between all members of the group. So a group can install some programs in the project and there is a way to share it with all members. So to install software, there are different steps. First, you need to get sources or binaries. So when it comes to install software, there are different steps to follow. So first, you need to get your source files or binaries, either by wget or git clone or any other means. Before installing, you need to load some modules and some dependencies. Eventually, you have to set some environment variables and so on. For compiling software, it depends on the software. Some software can be configured using configure or cmake. Then you compile the code using make. You can test using make test or make check, then make install. Most of users don't have to install any software in their home directories because most of used software is provided as a centralized HPC software stack. On Compute Canada cluster, we distribute software stack via CVMFs, which is CERN Virtual Machine File System. So we install the software locally, and all users can use it on all Compute Canada clusters. There is also some software that is provided locally, which is, for example, for VASP, it's tied to site. Each site has to install its own version of VASP. So the software stack environment on Compute Canada cluster comes on different layers. So we have the bottom layer here, which corresponds to operating system. This one is managed by a system administrator, so no one has access to this layer, only system administrator. And this layer can be different from one cluster to another, which means, for example, one cluster can use CentOS 7.6, another one can use 7.7. This is one of the main challenges of Compute Canada to come with software stack that will work on all clusters. There was another layer which provides Slurm and some Laster client libraries, Omnipath, and so on. These two layers are managed by a system administrator. Now there was another layer which is a NIX layer. This layer is managed by RSNT, Research Support National Team. This layer provides most of the libraries that are supposed to come from the system, operating system. So this way, our software stack will become independent from the operating system, as much as possible from the operating system. Another top layer is EasyBuild layer. So for this layer, we provide all the compilers, for example, OpenMPI, CUDA, libraries, and many other programs that are engineering, bioinformatics, physics, chemistry, and so on. There was another layer which is just for users. So users can install some programs in their home directory. If they have homemade programs, they can install Python packages and so on. So software installation on Compute Canada is done by RSNT, Research and Support National Teams. The main mandate of RSNT is to install and maintain software stack on all Compute Canada clusters. Also write and maintain the documentation. Of course, it's not only restricted to RSNT, but other members of CC staffs contribute also. So what is the software we install on Compute Canada? So we have a number of software environment like compilers, GCC, Intel, PGI, some math libraries like MKL, LAPAC, and so on, and other libraries for data, for example, HDF5, NetCDF, and so on. We install also profilers and debuggers. We have also installation of dynamic languages and interpreters like R, Python, and Julia, and so on. We install some domain-specific application like machine learning, biomolecular programs, genomics, chemistry, and so on. We also install some commercial and licensed software. So, for example, for ANSYS, we provide the program, and the users will have to bring their own license to use it. So at this time, we have more than 730 scientific application, which means all the different programs installed on Compute Canada. If we include permutation versions and architecture and toolchains, we have more than 50 to 100 modules. So the list of all the modules installed on Compute Canada cluster is available online, and this list is updated automatically, which means whenever we add a module to CVMFS, this page will be updated within 5 to 20 minutes later. We provide also many pre-built wheels for Python. The list is also available online. For more information about Compute Canada documentation, there was a wiki page for this. Now, the software is installed as modules, and for modules we use Lmod. So, some users are used to the old TCL modules. Usually they use module eval, but using Lmod, module eval will not show many modules. So the best way to find modules, you have to use module spider. Module spider, name of the module, this will give you more options. If there are many modules, for example, you will get different modules with version. Then to see how to load a given version of the module, you can apply again module spider software, name of the software version, and this will give you more option. If there are, for example, dependencies to load before the module, like OpenMPI, for example, or a given compiler, for example, module load GCC, OpenMPI, and the name of the module. In some application, user may need to access some information, for example, the path to installation module. For example, for Java application, it's always required to have the path to the installation directory. So to see that information, you can use module show. It will show you a list of information. Among of this list, there is a path to the installation directory, which is in our case start with eb root followed by the name of the software. Also, when you have to use many modules, it's always better recommended to list the module, because sometimes you load some modules with Intel and you load another module that is available only with GCC. For example, it can switch compiler, so to know better what modules you have in your environment, use always module list. When you install software in your home directory, you can also set modules. There was a way, there was documentation for that. So this is not subject for this talk, but there was documentation to do so. Now on Compute Canada, so we have a minimal installation for some programs. For example, for R, we have also some R modules and bioconductor as modules. The rest of the packages should be installed by users in their home directory, because it's difficult to maintain complete R installation on the cluster, because we have a process to propagate the modules from cloud to all the clusters via CVMFS. If we have to maintain this for complete R, you have to compile the same program many times. So this way, for example, we have a minimal installation with the basics packages, and each user will add the packages they need in their home directory. It's similar for Python. We provide also minimal installation for Python, and most of the used packages are provided as say-by-stack modules. The rest of the packages can be installed in user directory. We provide also some pre-built wheels for most used Python packages. It's similar for Perl and BioPerl. So other software that can be installed locally, for example, if you have a homemade programs, we cannot install it in CVMFS because we cannot expose your program to general public. There was also some software that has a restricted license, which means, for example, a license that only one user or one group can use. So we cannot install this program on CVMFS. You have to install it in your home directory, and we usually help users to do so. Sometimes we get requests from users to add a patch to a given program, even if it's open source. In this case, we cannot expose your changes to general public, so in this case you have to install this program in your home directory. Sometimes we get also requests for development version. So on our software stack, we try to have a released version, but if a user wants to use the development versions, we also help install it in his own directory. There was a documentation about installing software in home directory on Compute Canada that can be checked on Compute Canada wiki. So to install R packages, for example, RGDAL or STAT or any other R package, you need first to load R module. Sometimes you need more than R. You need to load some dependencies like GSL, JAX, or anything needed. So then you have to launch R and to start to install the packages. The first time you install the first package, it will ask you that this library, CVMFS, and so on, is not right. It's normal to get this message because you don't have right access on CVMFS. So there was the program will give you an alternative, which is to use local library. You have just to answer yes, and that's it. This message, you will get this message the first time you use this a given version of R. If you try to install another package in the same version of R, you will not get this message. So a similar way for Python. For Python, we have minimal installation as a module of Python and say-by-stack. So for the rest of the packages, you have to create a virtual environment and install the program. Some users who begins with Python usually forgot to create a virtual environment, and they end up on with a message, for example, a read-only file system, because they are trying to write on CVMFS where they don't have write access. So to avoid these problems, you should always create a virtual environment, then activate it before starting to install any Python package. This is just an example. For example, to install CodeAdept, you pip install CodeAdept. This one is already available as a wheel. We have a script that lists all the wheels that are available on Compute Canada software stack. Just type available _wheels, name of the package. It will give you all the version available for a given package. The list also is available online. For some Python packages, you have just to download the source files and unpack and install using. Most of programs came with the requirement. You have to install first the requirement, which is using pip install -r requirement, then install the package using Python setup install. Sometimes you have to edit setup.py to customize some options. So a similar way for Perl, also you have to load Perl modules, and the first time you try to install it will give you an option to install locally. Just say yes and choose local lib. This way the packages you will install will be added to your home directory, and for the first time it will also ask you to update your bash RC. Say yes, because this will add some path to your bash RC Perl 5 lib and so on. And this is done only the first time you install the first package. For the rest of the packages you install later, it will not ask. But before installing other packages, you should also make those changes available in your environment. For that, you have just to source your bash RC, or the easy thing to do is just log out from the cluster and log in again. This is for other programs. You need to download the source and configure. So there are the main ways to configure. There are you can use configure or emake, but other programs comes with something else. So if your program uses configure, so you have to configure and add the prefix. If you don't add the prefix, for example, by default, most of the programs try to write under user local or something. That location is restricted to root, so you don't have access, and you will end up always with an error, read-only file system, or you need sudo access. So to avoid these problems, if you use configure, add the option ---- prefix and point to path in your home directory or project where you have read and write access. Similar way for emake, there was variable emake install prefix that point to installation prefix to avoid the problems with read-only file systems. Of course, there are other programs that don't use configure, don't use emake, but they use something. They come up with bash script or Python scripts. So most of the time, you have to edit those scripts and change some variables inside to avoid these errors with the read file system and so on. Now we'll introduce EasyBuild. So to explain EasyBuild, so in 2 words, which means that we use a program that builds other programs. So if you talk to someone that we are going to use a program to build another program, to say, oh, it's difficult, because already building a program is difficult. Now we have to learn another program that builds another program, so it's more work. But in contrary, it's very easy. So what EasyBuild do? So usually when you install the software, you have to come to go through many steps. For example, download the codes, load modules, set environment variables, configure, compile, install, set module. So EasyBuild do all this. So it has already some functions that automate all this. So all you have to do is just to come up with a simple text file, which is easyconfig, and it has some keywords. You have just to provide the value of each keyword, and the EasyBuild will do the rest. So EasyBuild automates much of what you do manually, so it's just an easy way to bundle all your commands in one text file. It was originated from Belgium. Now it's used by various sites worldwide, including all Compute Canada clusters. So it has three main components. The core of EasyBuild is called framework. It has some high-level Python script. Second layer is EasyBlocks. There are some programs that need more settings, for example, different options, different settings. All this, for example, for WARF. So people come up with some script Python that automate all these options. And the last layer is easyconfig. It's a simple text file that has only some keywords and their values. I will give some examples later. So framework is the core of the EasyBuild, so it has all the functions that do all the machinery for EasyBuild. It downloads the sources, it unpacks the sources, it configures, it builds, it installs, it will install the module. All the machinery is done with using framework. EasyBlocks, as I said before, they are some Python script to build some difficult programs like WARF, Siesta, or VM2K, and so on. There was also in addition to EasyBlocks, we can also add some extension. For example, if you install a program that has Python dependencies or R dependencies, it's also possible to include them with the same module. The last layer, what we use usually, we don't change, as a user, you don't have to change the framework because you cannot do that. Maybe you can develop EasyBlock if there is no EasyBlock for your program. It's a Python script. For the last one is a text file that have some keywords. All you have to do is just to provide the values for this for each keyword and try to build the program. So there are many easy configs. You can check, for example, all the available easyconfig parameter using the command easybuild minus available easyconfig parameters, or eb -a. It will list all easyconfig parameters. To see the EasyBlocks, there was also a command eb -list EasyBlocks. It will give you all the EasyBlocks available. There are, for example, for WAR, for Siesta, and so on. Now, if you want to see all the software that is supported by EasyBuild, you can use this command eb -list software. It will take some time to produce a list, but last time I checked, it produces more than 200 different programs. If the installation is successful, there was a copy of easyconfig added in the installation directory. So, working with EasyBuild, what are the basics? What do you need to use EasyBuild? First, you need access to EB command, which means that EasyBuild is installed on your system. So it's already installed on all CC clusters. You need also to access to Toolchain. Toolchain, which means you have to know which compiler, which OpenMPI, and so. EasyBuild has a command that lists all the toolchains that are supported. Just eb list toolchains. It will give you all the toolchains available. So you can also search for the existing recipes. So the easy way is just to use eb capital S, name of the software. It will give you, it will print something if there was a recipe. If there was nothing, it will return nothing. So you can also go online. So the Compute Canada GitHub, the list is all the recipes used on Compute Canada can be found there. You can also use the official GitHub for EasyBuild, but if you use that, you may need to adapt some recipes because we don't have the same toolchains, for example. You need also to access the source files, so either via network or locally. So EasyBuild can just download the source file because you have to provide the URL where to find the source file. If not, you have just to provide the source files locally. So if there was a recipe, you can use the existing recipe. Sometimes you have to customize the recipe because some programs changes from one version to another. So from time to time, you have to edit the recipe and change something. If there was no recipe, you have to write your own. So, but you can start from existing recipe and change just to make it easier. So the syntax for building software using EasyBuild is easy. Just eb your recipe and plus you can use one or more options. To see all the options, you just eb -help or capital H. So what are the toolchains? Toolchains are core modules in EasyBuild concept. So they are a combination of different elements. For example, a compiler, the toolchain with GCC, Intel, PGI compiler, and so on. It can also contain MPI implementation like OpenMPI, Intel MPI, and so on. You can also add another element, which is, for example, MKL, Scala Pack, and so on. And there was also CUDA, so which means a combination of one or more elements from the above. For example, on Compute Canada, we use, for example, ICC-I4, which provides only the Intel compiler. If you take, for example, EOMPI, it provides Intel and OpenMPI. If you add the letter C, it means Intel OpenMPI plus CUDA. For example, EOMKLC, Intel OpenMPI, MKL, and CUDA, and so on. So most used toolchains on Compute Canada software stack are GCC 5 and GCC 7, Intel 2016, Intel 2018, and there's the software compiled with GCC 5 and Intel 2016 is provided as standard environment 2016. There was also another with called standard environment 2018. So as I said before, easyconfig is a simple text. This is one of the examples of the text. So this is for example, the EasyBlock. It says configure make, which means that this programs need to use the steps configure, make, install. There are others, for example, CMake, make CP. So you will choose one which is appropriate to the program. If you don't see this easy block in the recipe, which means that this software uses an easy block, which is a Python script that is written already for this software. In the recipe, you will provide the name of the software, the version, a homepage where the software is available, short description, and also toolchain to use, toolchain, the version of toolchain, and some options, the sources. And there are other options for sanity checks and so on. There is at the end module class, the category of the program, just to classify the modules, chemistry, bioinformatics, and so on. Of course, there are other options. For example, build the dependencies. On some programs, you need, for example, emake just to build the program, but it's not used when you run the program. So you can use it as build dependencies. For other programs, you need, for example, to run some commands before configuring, for example, to export MKL path or something like that. Some programs don't provide, for example, install command. For example, it works with configure make, but you cannot run make install. So in this case, you can just use skip steps, and you will skip this option. So where to find the recipe said already. You can just go to online or search, for example, on the cluster using EB-S. So this is just where to find the recipe. Now, a few weeks back, we can install software on Compute Canada without adding checksums. And recently, they enforced adding checksums, which means that you will need to add these checksums to your recipe. If you didn't add, there was an option to compile without checking this parameter, which is -- disable enforce checksums, or you can add them manually. For example, you have this line checksums equal and add it to your recipe. There was also EasyBuild can add checksums. So EB, the name of the recipe, means inject checksums. This command will inject the checksums, but it will not compile the code. It just it creates a temporary file and add the checksums. Then you can use the same recipe without this option, disable checksums. So there are more options, for example, and the most used, for example, is -try toolchain. For example, if you have a recipe that works with GCC 5, you can use it to install the program using GCC 7. For example, EB, name of the recipe, -try toolchain GCC 7. There are another most used option is -try software version. For example, if you install, for example, one version, software with one version, if the software don't change from one version to another, the recipe will work. Just use the same recipe -try software version and another version of the program. When you install using EasyBuild, sometimes you want to compile the code that is already available as a module. So in this case, EasyBuild will tell you there was nothing to build because it finds already the module. So if you need to recompile this module, you have to add the option -force to force the compilation. When debugging, for example, installation, you might need to access the build directory. By default, if the installation is successful, EasyBuild will remove the build directory. It's a temporary directory that will be cleaned if the installation is successful. But if the installation is successful and you want to keep that directory to check something, you can add the option -disable cleanup build directory. There are also other options, for example, to control how many threads to use when you compile a code. Some programs fail if you use more than one thread. So you can use the option minus parallel equal, for example, 1, 2, 3, 8. There was another option minus robot. For example, if you have a program, a recipe that has some dependencies, if you can try to compile the code and add, if the dependencies are missing, you can add the option minus robot, which means that you will compile the code and its dependencies at the same time. Sometimes it works, sometimes you have to fix a few things. There are also some options to customize the path of the module where to install the module. If you want to install the module in your home directory, or you can also change the path to software, for example, into project or any other location. So this is an example of a recipe. This is for Stata, which is a program that is close to R. So it uses Toolchains system. It's a simple recipe, few lines. So for example, if I want to install this, if you install it in on Compute Canada, by default the modules are installed under .local EasyBuild. There are 3 directories, one for modules, another for software, another for sources. For example, in this case, I want to install the program in project that the members of the group will share the location. So I can change the path for the software and install the module under project, and put the module in the home directory and install the code. So all the group has to do, just share the location of the project where the program is installed, and give access to all members of the group. Also, they can just copy the module from the person who installed the program and pass this module to other members of the group, and everyone will have access to this module. Of course, this is one way to do it. There are other ways. You can install everything under project and add the module path to that project. So there are different. I have here some examples. For example, this is Blast version 2.10 built with GCC 7. This is, for example, Diamond 0.8.36 with GCC 4, and this is the second box, just how to build it. Just EB, name of recipe, and that's it. If it works, otherwise you have to fix few things. So I will just show a few easyconfig. This is, for example, GSL, GNU Scientific Library. It uses configure make. So, and we have here Toolchain GCC 7. And this is different ways to build. For example, here I use, for example, -force, because this module is already installed on the system. If I want to switch the version, I can just EB GSL 2.4 GCC 5 -try Toolchain GCC 7. I can also switch to Intel and so on. There is another recipe. This one uses make. So you can see here there is a separate build directory. When you compile the code using CMake, usually you have to create a directory and to go there, then start CMake. This is another one. This is CMDCP. So this category of the programs don't have configure, don't use CMake. You have just to write some commands and copy the files. Whenever you use EasyBuild CMDCP, you have always to use this option, files to copy. So you compile and you copy the binaries and the libraries to installation directory. This is another This one we use emake, but in this case it has a different option. When you configure, there was a long list of configure. I didn't put all the list here because it's very long. It will take 2 slides. For this, for example, there was a way, some programs, when you download the source files from GitHub, they are not complete because you need to download recursively. So you can use this option and it will download all the related files for the program. This is another one which uses make CP. So I have just the program comes already with make file. So all you have to do is just compile using make, then copy because it don't have make install. So you have just to copy the files. Now I will switch to cluster to do some demonstration. So here's my terminal. I'm using our build node. So probably on the clusters will be slower because there are many users using a login node. So for example, if I want to install GSL, for example, I have just EB GSL. Since this version is already installed on the cluster, so I will just add -force, otherwise my recipe will not work. For example, if I want, instead of installing GSL 2.4, I want to install it with another toolchain. So for example, -try toolchain equal GCC 7.3.0. So that's it. So while waiting for this to be compiled, I will switch to another terminal and try another program. For example, I will just edit this. Add mixture is another program. So for this, it uses system toolchain, which is a new toolchain. Before we use dummy toolchain. I can go back to. I can change it back, or I can just use this one. For example, I will show you what happens if the recipe fails. For example, I will just change this one because this recipe should work, but if I have to put something here just to make it fail. So now if I EB -force, since it's already installed, so the first still running, still now it's building. So for admixture now it's almost done, but it's doing some sanity checks and it fails. So when a recipe fails, there was a temporary file, which is this one. You have just to edit the file and see the errors and fix them and continue. So I will just change what I did firstly. So this way the recipe should work. Now let's jump to another one. For example, this XML GONPI. So this program comes already with make file. So we use EasyBlock make CP. So we have here build options because it comes already with a make file called makefile.mpi.gcc. So to compile it, just EB, for example, -build is the same as -force. So I see that if I go back to GSL, it's still not built yet. So now it's done. So if it's done correctly, you will get this Message completed installation ended successfully. It took 2 minutes 16 seconds. The same I can use the same recipe to build, for example, GSL using Intel. EB GSL. Since this one is already installed, I will add force again. Minus try. What about if I want to have another version of GSL 2.5? Try software version equal 2.5. After the seminar, we will put this example the same location as the slides, so everyone can have access to them later. So admixture was compiled successfully. Now if we try, for example, another one, this one. This may take some time, but I will just to show you something. So this one is just a binary, but it comes with some dependencies for Perl. So we have Perl as a module here as a dependency. Since we don't have all the modules installed with Perl, so this one needs some extra packages. So this is extra default class Perl module, extra list. You provide the list of the modules that are needed to be installed, and the recipe will install them. So if I want to install this, eb -rebuild. Note that I use for this demonstration I use -rebuild or -force pieces. These programs are already installed in the system. That's this way I have to force the installation. So you see, for example, here when I try to use GSL .4 to install GSL .5, it complains about checksums. Now I can avoid this by adding the option -disable enforce checksums. So we'll come back a few minutes to it. So this one also, it says missing checksums. So I have to add the same option -disable enforce checksums. So see here, I started RxML installation. It's already done. Now if I want to install the same program, I have to switch, for example, toolchain. -try toolchain equal, I will take 2018 GOMPI 2018.3.312. So this means GCC 7 validating try toolchain or call name. Yeah, yes, there was a comma here. So GOMPI versus GCC 7 OpenMPI 3.1.312. So if I come back to pfam scan, it's now it says here installing extension. So it unpacked the code. Now it goes through the list of the extension of all the Perl modules that are needed. So it will install one by one. We have here 32 different Perl modules to add. So I think we still have 10 minutes, so we'll keep that for questions if there are some questions from the audience. Alex, did you get any question on the chat window?
No, there were no questions about the presentation, just the audio issues. So please feel free to unmute yourself and ask questions via audio, and also you can type them into the chat window.
Oh, there was a mistake here. 2018, not 3000.
Hi, I have a question.
Yes.
So I was curious if you're using RPath for your Python install, the way that you demonstrated doing the virtual env. I was curious if you have any trouble both with module loaded Python and then virtual enving that.
We don't have problem. I'm not expert in Python, so I don't install many Python packages, but most of the packages are provided as waves. They usually work without any problem. But I don't know the details how they build all the waves, so that's...
There is a question in the chat window. What would be a good reason to install software myself rather than requesting an installation?
Yes. There are different situations. For example, if you have a software that is a restricted license, you cannot install it on CVMFS, so you have to install it in your home directory. EasyBuild can help that automate if you have different version, for example. Some users develop programs. So they have different versions, so it's easy for them to use different modules. Using EasyBuild, you install the program, you have a module, you change the version, you have another module, and so on. For example, if you have you came up with a change in the program, I got a request from users to, for example, to add a patch to a given program, even if it's open source. We cannot do that, for example, because you change the program, you are responsible for that. We cannot expose the changes to general public. So in this case, you have to install it in your home directory. So that's there are different situations to do that. So for this last, so it installs RxML using another toolchain 2000 GeoMPA 2018. For that with Perl, it's still running.
There is another question from Oleg. Can you open the chat window and read yourself, Ali, or do you want me to read the question? It's fairly long.
Let me, I think I don't. No, I cannot.
Okay, I'll read the question. If I patch modify VASP, the VASP package, would it be possible to take advantage of the existing installation since it's properly configured, then build on top of this for my internal use?
Yes. All you have to take, just take the recipe as it is, as one line patch. That file. That's what I do when users come with some changes in the program, small changes, of course. Add just a patch, one line in the recipe, and compile your code, and you are done.
Okay. There's another question from Kenneth. What is a good way to get help with EasyBuild if something doesn't work and I can't figure it out myself?
That's you can ask experts. You go to online. There was a mailing list. You can. There was also you can join EasyBuild Slack. I did that already. So in my case, when I started, I was asking Maxim and Bart who installed EasyBuild on, or more involved in EasyBuild installation.
Okay, there's a question about recorded presentation. So just a reminder, I pasted the URL for the slides and the recorded presentation. So later today, we're going to add the slides to that link in the table of the list of webinars. Click on the current webinar, and that will take you to the to a separate page. So that we will post the slides today, and sometime next week, we're going to post the screencast video once it's processed. There is another question. Is there a nice way to properly delete a past installation and associated modules for cleanup?
To delete, I think there are options. Yeah, I think there are options to do that. Yes, I don't remember the option, but there are options for that. Just use eb-minus help. You will see more options.
I had another question.
Yes.
I guess going back to the terminal that you had there, it looks like you've got a architecture-specific path name.
Yes.
As well as 2017. I was just curious how that's put together, and then does that show up in your modules, or do you guys?
Yes. What we have
multi-arc that way?
What we have here, for example, when we started with Compute Canada, we started with Cedar and Graham, and some nodes have this AVX2 architecture, and when Beluga came online and the Niagara, they have new nodes, which is AVX512. So when we build the software, we have a flag to use which architecture. So have just RSNT underscore architecture, we use AVX2, AVX512. We also provide for SSE3 for all the legacy clusters. So, and now, for example, on build a node, we have a system we build for AVX2, then we build for AVX512, and each cluster is configured separately. For example, on Cedar, if you want to use AVX2, you can just do that. For Beluga, it's AVX512. But if it happens, for example, a user want to use a module that is built with AVX2 on Beluga, it's possible just to switch architecture, module load architecture AVX2, and mod the same module that worked on Cedar. The module is not optimized for AVX512, but it still work.
Can you demonstrate that? Like, can you go to the terminal and just show the
module? Yes. For example, if I go on build a node, we have the same environment. So if I want, so module list. So this is by default we have standard environment 2016, and if I want to jump to change the architecture, there was a module load architecture AVX 512. So this way I am in the same environment as Beluga.
Do you mind doing a module show on that ARC AVX512?
Yes, module show. Just it points to custom module here. Just change the path. Let me just. Those are questions for Maxime and Bart. Yeah, if model spider, then prepend path. It's just a path.
Very helpful, thanks. That's what I want to see. Thanks.
So Compute Canada software stack is used only on old system. For example, our local system at University of Manitoba, we have old architecture SSE3. We mounted CVMFS, and we can use some modules from CVMFS.
Okay, well, if there are no further questions, thank you. Okay, here's a question. There's a long question. Just came in. Some key easy configs like OpenMPI are agnostics of the scheduler integration. For example, Sloan with PMIX, and thus require to make systematically a custom local version. Would it be possible to have public easy configs for such cases, kind of flavor extensions like Slurm, to see the best practices in other centers?
That I cannot answer that because I know that Slurm is installed locally, and in our configuration we have some script to have different options. So that's I don't have all the details about that. Slurm is installed locally by system administrator. We don't know that.
Okay, well, thank you, Ali, for the great presentation. Thank you, everybody who joined us today. Any questions, you can send them after this webinar. Send an email to training@westgrid.ca, and if they're related to today's presentation, I'm going to pass them to Ali. And then next week, we're going to have in 2 weeks, 2 weeks from now, we're going to have a presentation on three-dimensional visualization in a web browser. Thanks, everybody, and I'll see you in 2 weeks.